In today's session, we're going to continue on the mindset of breakthrough improvement. And we've gone through our implementation series. This is the next video in the series to talk about managing priorities. So a lot of companies I go into, they have these problems, and it seems like all problems get the same level of attention. So we call it all problems are created equal. So what does that do to the organization? If we look at it, what we see is that our objective is to make sure that processes are highly reliable. So we want processes when they need to work, that they're highly reliable and can produce high quality and be highly effective. And what happens is when we have problems, we take action to deal with those problems in a timely manner. Then what happens is resources are overloaded with problems. So they don't have sufficient time to do the proper analysis on the problem. And then resources are overwhelmed dealing with those issues. Then what happens is there's many tasks that demand the resource time, and then the combination of those two resources spend time on non-value added activities reacting to problems, and then productivity and quality is reduced. And so the mindset that's causing all of this undesirable effects is that the problems are treated with the same level of priority. How do we go about changing that mindset? So what we want is a proactive mindset. So the company's issues should be prioritized based on the risk to the organization. So not the risk to the process, not the risk to a specific department, but to the risk to the business. So that's taking a different holistic approach. And what we say is all problems aren't created equal. So our objective is, again, to strive to have highly reliable processes. And if we have the mindset that problems are based and the prioritize based on risk to the organization, then what happens is the problems with the highest risk are prioritized. And then the desirable effect is the resources have the proper time to deal with the problem. So we're limiting the number of problems that people are reacting to. Then resources permanently solve the problems. Then there are fewer problems that demand resources time. Then resources spend time on value-added activities, and productivity and quality increase. So if we have a mechanism to assess problems and rank order those problems according to risk, and risk, we're talking about what's the severity of that problem from the organization's perspective, and also what's the likelihood of occurrence. And sometimes we put what's our ability to detect those problems. So those are the things that give us a risk priority number. And we focus on the highest ones first. If we Pareto those, we're going to look at the critical few and not worry about the trivial many. Next is talking about operations and orders going through the system. So how do we manage orders going through the system? So in theory constraints, we have buffer management as our method for managing orders through the system. So there's two types of buffers. The first one is a time buffer. The second one I'm going to talk about is the stock buffer. So a time buffer, what that is we're protecting due dates with time. And so each order in the system has reliable lead time. So that reliable lead time, if you go back to previous sessions, will tell you how to calculate those reliable lead times. So we take those reliable lead times, we have the order due date, we back off by the reliable lead time that gives us an order release date. And then we take that time, we split it into 3 equal zones. The first third of that order is in the system, it's green. The second third is yellow. The last third is red. So the priority is red orders get first priority, yellow orders get second priority, green orders get third priority. So no matter what operation the work is at, each order has a color priority. So it's a single priority system, not multiple priorities. Many companies I go into have multiple priority systems. This is a simple single priority system. So you work on orders that are in the red zone first, then yellow, then green. And remember our golden rule, we follow the rules. Work on red orders first, then yellow, then green. So this is a time buffer. So if you're make to order, engineer to order, configure to order, most likely you're going to have time buffers. Now, the other type of buffer is a stock buffer. So this is to make the stock items, or if we have an intermediate stocking location that we're setting up to make sure we have availability of components, then we have a stock buffer. So we calculate the target inventory based on the maximum consumption over the average replenishment time. So again, there's our replenishment time. And so we take the target inventory based on that calculation, and we divide it into 3 equal zones. So the upper zone is green, the next zone is yellow, the third zone is red. And so if we look at orders in the system and I look at my target inventory consumption point, I want to be about the middle of the yellow. So if the inventory is sized properly, the consumption point inventory is going to be about half the target. The remaining half of the orders are in process. So what's the color priority of these orders in process? So what we do is we look at the first order that's going to fill this slot in the inventory hole, and that order becomes yellow. The next order in process is going to fill the next slot in that inventory hole. That one's also yellow. And we go backwards through the process and we see the color priority of how those orders are going to fill the up to the inventory target up to the top of the green. Now we're never going to have more than the top of the green in the system. So we want to have what's in stock plus what's on the way, totaling our target inventory. Now, if there's consumption and this goes down, now the closest order to the stocking location is going to change color priority when we get down into the red. So it doesn't matter if we have a stock buffer or a time buffer, the rules are the same. The people at the processes don't know what type of order it is, whether it's a stock order or a make to order or an engineer to order. They follow the color system. So this color system is simple, it's easy, and we have the one rule: follow the color priority. So when we talk about supporting functions, what should their priority be? So it's maintenance, IT, HR, right? Any supporting function, quality, those supporting functions that are supporting operations. So what's their number one priority? Support the constraint. So if there's an issue with the constraint, that's number one priority. Next is, what's the process that has the most orders with the highest buffer penetration? So if there's a process that has significant amount of red orders and that process has a problem, that's our next priority. We're protecting the customer. So number one, always protect the constraint. Number two, protect the customer. And number three is, what are the processes upstream from the constraint that are most likely going to cause starvation at the constraint? We want to go look at those as a third priority. So once we get our priority system in place, we have a mechanism for assessing the risk to the organization. We can prioritize problems based on the risk. Then when we have operational issues, we're going to look at our buffers. We're going to look at the orders with the highest buffer penetration and focus on red orders first, then yellow, and then supporting functions follow the same priority listed here. When we do that, everybody's in alignment to a single priority system. So that's our session for today. Thanks for joining this session.